So we're looking at page 4. Yep, the reference angle is going to be how much did you say? 33. How'd you get that?
It's just 30 away from that.
Exactly. It's 33 away from 360. Love it. Did anyone else get 33? Love it. Negative 197 is going to take us where? To quadrant two. Wait. Oh, yeah, to quadrant 2. It's going to take us all the way up there, isn't it? Negative means I go down. So my reference angle is going to be to the nearest x-axis, this quantity. 17 degrees. Reference angles will always be positive. And we could always just do 197 minus 180 to get that 17. Love it. 563 is not quite as comfortable. 563, how are we doing that one? Let's take off a rotation to make it a little bit more comfortable. Agreed. 203, what quadrant would 203 be in? 90, 180, it's not, we don't go all the way to 270. So I'm going to say that's 203. My reference angle is going to be to the nearest x-axis, which is talking about this. How far is 203 from 180?
23.
Thanks, Ritz. Those are my 3 answers to that. Okay. Then I just wanted to look ahead a little bit. Name 4 angles between 0 and 360 that have a reference angle of 20 degrees. Anyone have any idea? If I'm talking between 0 and 360. Yeah, Harville, give me one.
20.
He's like, hello, if I just had a 20-degree angle to the nearest x-axis is 20 degrees. That's 1. 20 degrees is great. Ugh. Did anyone get another? Think of another. What also would have a 160 if I went around 160 degrees? Am I 20 degrees away from 180?
Yeah.
That would also have a reference angle of 20 degrees. So that's 160. What would be another one? Negative 20 degrees. If I went down 20 degrees, does that have a reference angle of 20?
Yeah.
Agreed? Oh, wait. Yeah, they had to be between 0 and 360. Silly us. So, Cooper, I like what you're saying, though. Could I go a positive way to get to that same location, Coop?
340.
340 is the positive way to get to that same location, Cooper. Perfect. 340. There's got to be one more. 200, I heard it. 200. If I went 90, 180, a little bit past it to 200, 200 is 20 degrees away from 180. Well done. Well done.
I want to know the answer to that.
To this guy? Wait, which one?
The SAT one.
Yeah, let's do it. Does anyone remember? If this is just a flashback. Angle BOD is 15 degrees. EOA is 85. They want ECA. They want that. Yep. Anyone have any ideas?
Well, you can get 80 degrees for between the 80.
You're saying that's going to be 80? Because
Yeah.
these add up to 180? 165. Agreed, buddy.
You would.
This one out here.
Would you? I was thinking you tried sulfur.
Does anyone remember that this angle, 85 degrees, corresponds with that arc? This is called a central angle. Goes with that arc. So that arc would also be 85. So therefore, what would this arc over here be?
15.
Agreed. Then there's a theorem that we really don't remember, so I'm here to remind you. In order to find this little angle, it's 1/2 of this arc minus that arc.
Oh.
Whew. So it's 1/2 of that 85 minus the 15. Exactly. 85 minus 15 gets me 70. Half of that is getting me 35. Just a little refresher for us. That's a lot. Those are hard. Circles were hard in geometry. Do we remember how to simplify something like this? Whew. And so I want to do this We got to do this to prep us for some stuff that we're going to deal with. So I just wanted to make sure that we feel good about it. Definitely grab calculators. Definitely have calculators. Square root of 512. We need to get it not as a decimal. We need to simplify the square roots. So we got to think, what goes into 512? The bigger the perfect square, the easier life will be. If you do small ones, it's fine. It'll just take us more steps. What goes into 512?
256.
What? It's divisible by 2 and 256. Okay. So that's one way we could do it. Did anyone come up with any others that multiply to get me together to be 512? Yeah, Mace. Ooh. You want to know why I like that? I like that a lot. 16 and 32. Here's the deal, you guys. If I were to rewrite the square root of 512 as the square root of 2 times 56, have I changed my problem? 2 times 56 is still 512, right? I haven't changed it. What if I did a 16 times a 32? Oops, a 16 times a 32. Are these still the same? Yeah. So it's just important to keep it, making sure that the values are still there. So then, you guys, I want you to know this is the same as the square root of 2 times the square root of 256. Just like Macy's is the same as the square root of 16 times the square root of 32. You can break them apart. You guys, do we know what the square root of 256 is?
16.
Yeah, so what does this simplify to be?
16 root 2.
Hey. What would I do over here if I went Macy's route? What's the square root of 16? 4, and then I'd have a root 32. Could I simplify root 32? What could I break that down into? 2 times, I could say root 2 times root 16 is still root 32, right? What's that getting me?
4 times 4 times.
Right, that's going to get me another 4 times that 4 gets me 16, leaving me with a root 2. So Mace, can we get there the same way, doing a different option? Absolutely. Then maybe in my calculator, I just double check. Is the square root of 512 the same thing as 16 root 2? And I feel great about it. What if I give you this? Let's go with square root of 192. We're simplifying the square root of 192. Like that. So are you saying square root of 64 times the square root of 3 is the same as the square root of 192? Beautiful. Vise, what's the square root of 64?
8.
Boom. Are we done? Yeah. And then we might double check. Is the square root of 192, is the square root of 192 the same as 8 square root of 3? And I feel great. Did anyone do it a different way? What did you use, Biscuit Baby?
32 and 6.
Oh, okay. Square root of 192, square root of 32, and the square root of 6. Square root of 32, then what'd you do?
I didn't really do that much. I just did that.
Oh, I got you. Oh, you're like, okay, here's where I am. What can we break 32 into? 16. Root 16 times root 2 is still the square root of 32.
And then,
And 6 is 2 times 3.
yep.
Okay. Biscuit Baby, do we know what the square root of 16 is?
Yeah, 4.
Hey. You guys, do we know what root 2 times root 2 gets me?
2.
2, right? Because it would get me root 4, which is just 2. So that would get me another 2. And then that root 3 just chills. What is 4 times 2? Do we get the same answer? Yeah. So Biscuit Baby, totally doable. The only thing that I the reason why VCs took less steps is because we were able to break it into some perfect squares. Do we have to? No. Just might save you some steps. What happens if I give you this? Y'all, I need to know what X is, and I don't want it as a decimal. What theorem we doing? Pythagorean, how does that get set up? A squared plus B squared equals C squared. What has to be my C in this case? Yep. What numbers did we get that went into 850? 25. Ooh, why do we like 25? Because because it's perfect square. Does 50 go into 850?
Yeah.
Yeah, but it's not a perfect square. So I'm going to go with the 25. I dig that. 850 divided by 25 leaves me with a 34. So I got root 25 times a root 34. What's root 25?
5.
Hey-yo, what's root 34? 2 times 17, right? Root 2 times root 17. Can I do anything with those things?
No.
I can't. So I'm just going to say, okay, that doesn't break down at all. So I'm left with 5 root 34. Is 5 root 34 the same as the square root of 850? I'm going to check that in my calci, and I feel good about it. How about 12 and 11? Did y'all get 265 over here? And then when I'm asking for a square root and you're like 5 and 53 and any others? No. That's it. Is 5 a prime number?
Yeah.
53,
Yeah.
prime number. Can't do anything with them. You're done. This value is just square root of 265. Good call, good call, good call. Great. Okay, let's try this guy. That's an A. What are we finding that goes into 980?
I said 10 and 98.
10 and 98? Big ones. So we're saying 10 and 98, or what'd you say? 20 and 49. Ooh, why do I like that? Square root of 49.
6 and 5.
Say it again.
196 and 5.
Ooh, I really like these two the most. Why? Perfect square. 7, perfect square, 14. I dig it. Is this going to get me the right answer? Sure. It's just going to take a couple more steps. So I would have a 7 here. What about 20? 4 and 5. So root 4 times root 5 times a 7, right? What is root 4?
2.
2 times that 7? So that's getting me a 14 root 5. I dig it. Oh, I'm sorry, VC over here. What's the square root of 196, VC? 14, and I'm there right in one step. I love that. What about over here? What's square root of 10 going to be? Square root of times 2. I'm fine with that. Square root of 98. Got some options. Say it again.
If I did 49
49 and 2. I dig it. What's the square root of 49? 7. What's this what is this going to get me? Square root of 2, my bad, times the square root of 2. Square root of 2 times the square root of 2 is the square root of 4, which is just a 2, leaving me with that root 5 on the end. So again, we get the same answer no matter what. I could not care less how you get there. Could some ways be a little faster for you? Sure. Doesn't matter. What happens if I get an answer? We're going to get into some SOHCAHTOA is what we're getting ready for. Does anyone remember what SOHCAHTOA stands for? SOHCAHTOA.
Sine opposite over hypotenuse.
Mm-hmm.
Sine adjacent tangent opposite over adjacent.
Yeah, so let's go back to what VC said of a 5, 12, 13. VC, if this was a 5, 12, 13. This is just a little pre-teach. You don't have to write any of this down, but you know what you need to do is listen. Ryan, I'm looking over you, okay? Okay. So question, if this is my angle, I don't remember what the sine of my angle, you could just be a little sponge here. You don't have to write this down. The sine. Sine goes with SOH, so opposite over hypotenuse. If that's my angle theta, the sine would be opposite over hypotenuse, 5 over 13. What if my angle was up here and I'm going to make it a beta? What would the sine of beta be?
12 over 13.
Opposite over hypotenuse would be a 12 over 13. You okay with that? What if I asked for the cosine of theta? So, what would the cosine, the adjacent over hypotenuse be of theta? Adjacent over hypotenuse is 12 over 13. And what about the cosine of beta?
5 over 13.
Adjacent over hypotenuse would be 5 over 13. Okay. Last one. Tangent of theta. SOHCAHTOA, opposite over adjacent. Bless you. Opposite over adjacent would be 5/12. And then tangent of beta. Tangent is SOHCAHTOA, opposite over adjacent, 12 over 5. Wait, did I do that right?
Yeah.
Okay, so these ones just flippy floppy. Great. Okay, here's my question. If your answers finish this way, you're good. What if an answer finishes like so? 5 over root 17.
You can't have a square root.
We can't have a square root in the denominator. So how do we take care of a square root in the denominator is my pre-teaching I want to handle. Can't square it.
Just multiply by the denominator.
What is root 17 times root 17?
1.
Gets me 17. If I multiply the bottom by root 17, what do I have to do on the top? Why do I need to do a root 17 on top? What's any number over itself? What would this simplify? Just to be 1. So I'm really multiplying this guy by 1. What would I get on top when I multiply by a root 17? 5 root 17 over? Can we cancel these guys out? No, because one guy's a root and one guy's not. Okay? Okay. So I do want us to practice something. I want you to write this on your board now. What if we got 6 over 2 root 5? What's the only thing we have a problem with? Do I have a problem with the 2 on the bottom? No. What's the only thing I have a problem with? That root 5. So you guys, we got to multiply by that root 5 on the bottom. If I do that on the bottom, what do we got on top?
6 root 5.
Yeah. So I'd have a 6 root 5 over, what's this going to get me? Yeah. My root 5 times my root 5 gets me a 5 times what I already had there. Can anything simplify? 6 and 10. Are they either of them under the root? No, so I can simplify them. What would 6 over 10 simplify to be? Say it again. Divided by 2 would be 3 over 5. Agreed. Question. Could I have simplified that 6 back here? 6 over 2 to get a 3 right there. You know what I'm saying? Just different options. Here we go. We're going to set this up. And we're going to say, give me any number out there. 6 and 12. I heard it. Boom. And I'm curious, what is... Okay, first I want you to find x. Let's start with that. What are we breaking 180 into?
36 and 5.
36 and 5. I like 36. Why do I like 36? What is the square root of 36? Beautiful. So you guys, this one is now 6 root 5. Let's go make the decision. You can erase this work here if you want, because I'm going to ask you for some things. I want, if this is theta, the sine of theta, the cosine of theta, and the tangent of theta. This is really a pre-teach. Don't feel like, oh my God, if you're like struggling with this, that's okay, because I haven't really taught it. This is me just trying to get it in our brains before I teach it to you again on Monday. Let me remind you, we got SOHCAHTOA. So the sine, let's just start with sine. Sine of theta, so SOH. What would be my opposite over my hypotenuse? Agreed. Would you want to cancel anything out first, buddy? Can we just go like that? Psh. What's left, though, if I do that? Very good. I'm left with a 1 over a root 5. What's my problem with that? The root can't be in the denominator. So what do we have to do? You got it, bud. Top and bottom with a root 5. What am I left with?
Root 5 over 5.
Root 5 over 5. Well done. I want you to go try that with cosine and tangent. Cosine of theta, adjacent over hypotenuse, 12 over 6 root 5. Want to simplify that at all? Yeah, I'd go make that a 2. And then what would my final answer be? Yeah, multiply by that root 5, and I get a 2 root 5 over 5. Not canceling these guys out because one's in a square root, right? Beckett. Last one, the tangent of theta. 6 over 12 is just beautiful. Last one, you make it up. Well, give me a number.
25.
25. And 3? Nasty. Go for it.
Yeah. Wait.
Did you guys get 616?
Yeah.
Gross. Is that breaking into anything?
4 is 150.
Okay, we like that. Oh, really? 154 is not divisible by 4. Oh, snap. And 2, I agree. That's as far as we're going, because then we got 2 and 77. That's going to be 7 times 11. So what's that x going to equal?
2 root 154.
Well done. 2 root 154 is nasty. But we can do this, y'all. We can do it. I moved theta. Theta's up here now. I'm crazy. Sine would be what over what?
3 over 25.
Opposite over hypotenuse. Can we do anything with that, Ritzy? No, we're done. Cosine. So ka, adjacent over hypotenuse. What's adjacent to this guy?
2 root 155.
Well done. Over? Okay. Can we do anything to that?
No.
Do I have a square root in the denominator?
No.
I'm not mad at it. Harville, keep it away. I get that you're done, but chill. Tangent.
3 over.
Opposite over adjacent. What's my only beef here? What part of the denom?
154.
Yeah. What do we got on top?
3
Over
308.
308. Do these simplify at all? 3 308s? I'm going to just check. 3 308s?
No.
Nope. We're done.